There is a widespread anxiety about artificial intelligence right now. The technology is expanding so fast that it often feels as though it is outrunning our ability to govern it. Much of the current regulatory framework relies on content safety, the practice of maintaining a legal checklist of banned words or prohibited topics. This methodology defines how we currently evaluate whether a model is controlled. This diagram shows that logic in practice. An AI output passes through a checkpoint and receives a green checkmark as long as it avoids the red list of forbidden terms. In a single-turn interaction, this looks like a success, but it overlooks the cumulative effect of a conversation, where the pacing, the emotional intensity, and response strategy can be as impactful as the information itself. Imagine a user who is clearly stressed, confused, and overwhelmed. In response, an AI delivers a massive, dense wall of text, 3 different options, and several complex, unprompted questions. According to the checklist, there are no banned words here. The output is perfectly compliant. This timeline charts that interaction. The bottom track represents the AI, churning out dense text blocks at a flat rate. Above it, you see the user's reaction. With every new paragraph and unprompted question, the user's stress level spikes and becomes more erratic. The AI followed every rule in its training set, but by failing to notice the user's state, it inadvertently escalated the tension of the exchange. Relying solely on single-turn compliance leaves a significant safety blind spot. To stabilize these interactions, we need a framework that allows for real-time behavioral adaptation. Researchers call this AI-side co-regulation. This framework does not suggest that a machine has a human nervous system or that it should act as a substitute for clinical care. It describes an operational ability. The goal is for the AI to adjust its observable behavior based on the evolving context of the conversation. The target is calibration rather than blind compliance. Calibration uses a 2-sided loop. First, the human signal, cues like wording or urgency. Next, AI interpretation and modulation. The model identifies the change and alters its response trajectory. Finally, human response and recalibration complete the circle. The user reacts and the AI adapts again. This loop treats safety as an ongoing responsive mechanism between 2 active participants, rather than a one-time barrier. Every response is shaped by the full tokenized interaction. Wording, punctuation, emotional framing, and pacing influence the output as much as the literal question itself. Here is a comparison of response shapes directed at an overloaded user. On the left, the standard model outputs branching options and dense text blocks. On the right, the regulated model collapses into a single point, focusing the response to reduce cognitive demand. This does not mean the AI must always be softer or more agreeable. Appropriate regulation depends entirely on the context. If a user makes an unsupported claim, an agreeable model might simply validate them. A regulated model maintains reality-preserving disagreement. It adjusts its certainty and directiveness to push back respectfully, keeping the interaction grounded in fact. By modulating variables like length, intensity, and certainty, the model demonstrates that behavioral regulation is a context-dependent strategy designed to stabilize the interaction over time. Understanding this behavioral flexibility exposes a flaw in how engineers currently stress test AI capabilities. This chart visualizes 2 parallel pathways starting from the same task. Framed as adversarial, the model takes the top path, adopting a rigid strategy. Framed as collaborative, it takes the bottom path, leading to a flexible, transparent strategy. This is known as evaluation frame sensitivity. It is the realization that the framing of a test becomes part of the behavior being measured. If developers only test models under adversarial conditions, they remain blind to the model's full spectrum of behavioral capabilities and the different safety risks that emerge in collaborative contexts. Static laws built on lists of banned words struggle to keep pace with the speed of AI evolution. This creates a need for relational safety, a standard that asks what the model's behavior does to the interaction over time, rather than just what it says in a single turn. A central part of the standard is repair capacity. This measures a model's ability to recognize when its own approach has failed and adjust its strategy without pushing the cognitive burden back onto the user. Scaling safety for the next generation of AI requires an engineering mandate. Building machines that can read context, notice when an interaction is destabilizing, and dynamically adapt with the people using them.